So here's the problem with Artemis 3. NASA wants to send astronauts back to the moon, but one of the most important parts of the mission still hasn't been fully proven: refueling Starship in space. And if that doesn't work properly, the moon landing doesn't happen. Yeah, seriously. A lot of people think the hardest part of Artemis 3 is launching the rocket. It's not. The real challenge starts after launch, because before Starship can even go near the moon, it has to be refueled in orbit using other starships. Not one, multiple. Think about how crazy that already sounds. You're launching several giant spacecraft into orbit, carrying massive amounts of super cold fuel, then trying to transfer that fuel between vehicles floating in microgravity. And this has to happen with extreme precision, because in space, fuel doesn't behave the way it does on Earth. There's no gravity pulling it down into tanks normally. It floats, moves around, forms bubbles, shifts unpredictably. Now imagine trying to move huge amounts of that fuel from one spacecraft to another without losing stability, pressure, or temperature control. That's the part people don't realize NASA and SpaceX are still working on. And Artemis 3 depends on it, completely, because Starship needs a huge amount of fuel to land on the moon and come back. Without orbital refueling, it simply can't do the mission the way it's currently planned. And honestly, that's only one problem, because this mission is incredibly complicated. First, Orion launches with the astronauts. Then, Starship launches separately. Then, tanker starships launch after that to refill the moonlander in orbit. Then those vehicles have to dock correctly. Then, Starship has to travel to the moon, land safely, take off again, dock again, and finally, bring the crew home. That's a huge chain of events. And in space, complexity creates risk, because the more steps you add, the more opportunities there are for something to go wrong. And NASA knows this. That's part of why Artemis 3 keeps getting delayed. These systems aren't fully operational yet. They're still being tested in real conditions. And some of the hardest parts haven't actually been demonstrated at full scale. Now, to be fair, SpaceX has made serious progress. Starship launches are getting better. Docking technology already exists in some form. NASA has done complex missions before. But Artemis 3 is combining all these things together at a scale we haven't really seen before. That's what makes it different. Apollo was dangerous too, but compared to Artemis 3, Apollo was actually simpler in some ways. Fewer moving parts, fewer launches, fewer systems depending on each other. Artemis is trying to build an entire long-term moon infrastructure, and that requires a level of coordination that's extremely difficult, especially when humans are involved. Because if one launch is delayed, that affects fuel timing. If fuel timing changes, that affects docking windows. If docking fails, the mission changes completely. Everything is connected. And that's why so many engineers are paying close attention to this mission right now. Not because Artemis 3 is impossible, but because there are still major things that need to be proven before astronauts walk on the moon again. And until those systems work consistently, that uncertainty stays there. Because in space, missions rarely fail because of one giant, dramatic mistake. Usually, it's a chain of smaller problems building on each other. And Artemis 3 has more moving pieces than almost any mission NASA has ever attempted, which is exactly why it's so fascinating to watch. So what do you think? Do you think Artemis 3 will actually succeed with this level of complexity? Or are there still too many things that could go wrong? Let me know your thoughts in the comments. And if you enjoy videos about hidden space risks, mission problems, and the things NASA and SpaceX are still trying to solve, subscribe, because there's a lot more coming.